this 4-ton boulder that's the size of a car can actually be moved only using your hands. We can actually use this boulder to talk about the laws of motion, which were first described by Isaac Newton in the 17th century. So the first law describes that an object will not change its motion unless a force acts on it. So currently our boulder is stationary, but if I act a force on it, or if I give it a push, our boulder will start to move.
We're going to give our stunt tennis ball a little bit of a smack in 3, and 2, and 1. It's not exactly what we planned out there, was it? That's not exactly what we thought was going to happen. But if we have a look at the rest of the law, unless acted upon by another force. So if there were no other forces acting upon our tennis ball, then yes, it would have carried on that way forever. However, we have some forces acting upon our tennis ball. One of them is gravity. Gravity, that force that Sir Isaac Newton worked out and sort of discovered himself, is pulling the tennis ball to the ground. So that's going to slow it down.
Our planet is a complicated system, and when we move around in our atmosphere, we experience things like wind resistance and other forms of friction, which is a force that resists motion. This is what slows us down, requiring the application of constant force to keep moving. But think of something like a skating rink. The ice is very slippery. It is a surface with very little friction. If you gently push a hockey puck, it will glide rather far, much farther than if you pushed it on a table or on the ground.
You lift up a very heavy object, even heavier than this, and then you let it go, you swing it, thereby converting gravitational potential energy into kinetic energy, and that way you can demolish a building. You just let it hit, and it breaks a building. And that's the whole idea of wrecking. So you are using then the conversion of gravitational potential energy to kinetic energy.